Welcome back to Wickerson Studios. We are going to continue with the third video. Let me turn down my volume so I don't interrupt myself. And we're going to just continue with how you can run hops into Grasshopper. And of course, the last two videos show where you can get everything up and running, from Anaconda to the GH server to Visual Studio Code, get the hops node in here. And we're going to continue. And like I said last time, is I wanted you to go in and install point at, surface point, and rules. And then I was going to come back in and do something with complex numbers. So I've got my GitHub Copilot on. If you don't pay $10 a month for it, you're just going to have to watch this $100 a year is a discount. If you don't do that, you're just going to have to kind of play this video slow and kind of cut and paste it in, or wait till I have the app out. And the app's coming, and I'm going to start adding some little data visualization as we go. So I'm just going to squeeze this down here. And so you can do the other ones. I did their bin multiplier, and I made up a subtract node called subtract. And what's nice about Python is you can have the same names. It's not so type sensitive as C. So we're up and loaded, and I am going to show that I can just, with GitHub Copilot, get this thing up and running itself. So write a at hops dot component function, which is what I'll refer to it as. That's kind of what it is, that creates complex numbers. And I'm going to keep my hashtag going, and returns them as a list of points. And this will go in and use a little Rhino 3D, which I'm not too excited about. Rhino 3DM. You don't really need it, because I think you should do all the geometry over in Grasshopper. My firm belief is that you keep everything running over in Visual Studio Code that becomes a number, float, integer, maybe Boolean, and possibly strings, get through dealing with different data frames in series when we get on the pandas. But you'll see that in a later handout. Because it's quick, and the rest of it can be slowed down as you start to bring in vectors and points and have fun with that. But let's just run this one. We're going to let it set itself up as a at hops.component, parentheses, open and closed. We'll wait for it, and you can see the whole thing ran itself beautifully. Let's just check it. Description, complex numbers. There it is, and the function pops right in, and that is the magic of, now I'm not sure if I want that, real, imaginary, I used bigger words than I really wanted. No, real, imaginary, 0.3D. I could have brought them in under I could have just used R float and I float, and then have R and I, but since it's R, I, and imaginary, and 0 is the Z, it's a 0.3D. It should run and return, and what I want you to do is just wait for it and see what happens. What I may end up doing is putting in that Z component. I think that's exactly what I'm going to do. I'm going to override this, and I'm going to use a random uniform just to make this kind of fun. So I have a 0 here, but I want to make it so it's parametric when I bring it into Grasshopper. So we're going to call this one complex 2. We're going to go back up here, and we're going to put in complex. Well, since we haven't run it, we'll just leave it as complex. And I will cut back to here, and I'll put a little comma here, and then I'll bring in a hs.hops number and parentheses. Let's just see what it does. And it wants to count, but I just want Z. I just want to put in here, quote, a capital Z, Z, and the last Z, I want it to be Z component of the complex point number. All right. And then we should finish up by closing it out. We'll have our outputs will be a complex number as a hops point using and end that, and then open up our function float. And there it went to R, I, and Z float. We will import, because I'm going to need it, import math, and I'm going to import random, and I'm going to return, well, that's interesting. It found a way to do it, the Rhino point, except I'm not going to do all that. I'm going to do it as nice and simple, R-I-Z plus random, and I'll use uniform, and we'll throw that between whatever we want to cap the domain at. So we'll just go to -3 and 3. And I'm just playing off of past ones that I'd written, should end it up. And with any luck, that should run it. So let's take a little quick save and run and see if we have any difficulty. We did not get our AI address, so what did I do? Comma, Rhino return. I put a parenthesis here. It doesn't know what to make of that. Let's save it again and run it. Square bracket. There's our internet protocol, whatever IP address is. Used to be wise to that. We're going to pull it in here, and we're going to actually, I think before we do that, let's just keep it easy. Let's grab all this junk, cut and paste it, pull it down here. Let's change the name to a complex number. Complex number points, point hots node, and we'll just call it that. And we'll go down here and we can get rid of that subtract. We may use it and we'll change the name. We have the IP address. Let's see what we need. We're going to pull it in here and paste it in / grab the name complex. So we're just making up something fun. And now we can have our R value. I'm going to grab 2.000 and we'll copy that. Boom, boom, boom. And we should have our real number, our imaginary number, and how high we want to go in Z. And what happened? 217 says random point, return Rhino point 3DM point 3D. What? I have a little typo here that's not going to make any sense. I wanted negative, not underscore. We got to close out again down here. You stop running here. You can stop running here with Control-C. We'll save it again. And there may be a bug now. And this is where you're going to learn that if you run the same name with something already run, it can be a problem. And the other thing I want to show you is a set, and this is good to see that me do this because it's taken a whole lot of fidgeting and fallying, and I may have to rename complex as another number because it's trying to read it as that, but let's try the real, the imaginary, and the Z, and we should have, there we go, and we can actually grab that as a point, so we don't need this. We can just take our point and put it right into, sorry, we don't want to put our point into the radius, we want to put our point into the point, and we want to put our radius on, let's make the radius the Z. And that's not going to give us anything too funky complex, but I'm going to hit the left double hit. I'm going to grab the keyword complex. I'm going to right click now, put it in for hops, bypass the icon, go up here and make sure we get the right call and the right call. And that one had a problem. So let me see up here. You can see I just caught an error here. The keyword is subtract and subtract. So that's where it's just like making a nice script for everybody to see. And obviously right here, we want to have subtract as the word. And I should have got that last time. But now it's cleaned up. We can save it. And we've got another script to go. And if we wanted to double check what we have, we'll pull it out. And there it is. There's the complex number moving. And it's kind of not really in the complex realm because it's hard to see the complex realm. But it's enough to kind of play off of what a complex number would be and allow you to see that you're able to start using these types of functions in here. Nothing too fancy, but just thinking about the data that you might want to drive if you're going to deal with your maths and get into some of these more complex things that exist up here. And it will get more interesting in Grasshopper 2.0 as well. So that's kind of a novelty. It's not really that important. I'm going to save it. And now we're going to actually get into Python for data analysis. And we could say a little something about it if we want. I may take a break. I think we'll keep going. But I can tell you that Python for data analysis, you can really just kind of steal from whatever online sources there exists. So Python for data analysis, And if you need references, you can just start typing this stuff in. There's one right there. But let's take a look at data wrangling, because that's the book that I really am learning a lot of this with pandas, NumPy, and IPython. Except we're actually going to move it from, and here's Wes McKinney, and that's the one that really inspired me. So I'll take that, and I'll take his link if you want to see that. The other thing I want to do is import stuff, so I don't have to import these things in all those functions as I go. So import pandas as PD, import NumPy as NP, import Rhino 3D's already been done, but I'm going to just bring it in again. Rhino 3DM as exactly that. I'm going to import random all the time, not just in a function because we want it to be global. I want to, NumPy is already done, pandas is already done, and here's a little thing that he suggests, and I really like it. PD options, and it's not necessary right now. Rows set to 20, so you're capping your size. PD options display max, PD options display max. I'm going to set that to 20 as well. And then PD options display width, display maximum column width. Okay, rows, columns. We're going to go through here and do options. Oop, jumped out of there. Let's do here PD options display. Let's do display max column widths. Column width 100, and we'll change that to 80. And then we'll do a numpy.set print options. And this is just what I pulled out of a textbook. Print options, and we'll do precision 4 and suppress true. Okay, hang on. Set underscore print options precision true. Okay, so we'll leave it at that, and then we'll just save that, and we'll leave this so it can actually save. Once again, I like to come down here and hit clear. Just little simple Linux commands if you remember back to that or did any work on it. And we're going to start with NumPy basics. And at this point, I might go in here and say, all right, let's grab one of these because we're getting a little more interesting now. Let's jump in here and call this exactly that, NumPy basics. And we probably can call it, well, we already titled it, so let's just call it that, NumPy basics. And we can start a new column if you want to just have this kind of happen in stream, so we can come down again, but I don't mind going in deeper or longer. Well, forget it. We'll go here and we'll do this, and this size should probably, these were just introductions, so I'm going to grab this and slide this down here, and I'm just going to have NumPy basics doubled, and we're going to say introduction, intro to hops for Grasshopper in Visual Studio Code, and that's just going to be something to get us moving. And I think what I'll do is just bring it down here. There we go. And NumPy basics where we're going to go and see where this goes, and file save. So I'm ready to run, and I could take a ton of notes by just asking questions about all of this information out of the textbook, and I could really rewrite it just with GitHub Copilot in and of itself. But it's best to have a textbook on the side. I'd recommend buying the one that this one recommends by Wes McKinney. But there are a couple of scripts in there that really stood out to me, so I'm going to start here and just write one. And what's nice about this terminal down here, and here's something I forgot to show you. Whenever you have something, right-click on it and take the cache and take the memory off. You also might want to go in here and hit preferences and keep clearing these caches on the main board. But if you do this, then you will be able to see the updates every time you slide through these nodes. And there is a catch when you load these, and I'll show you those at a later date. But we have 3 here, all ready to run. So then when I actually run this complex number, you see it keeps generating new randoms for that Z down in our terminal. and giving us new data. It doesn't actually save or cache anything. If you want to cache things, then you know it's always going to go back to that. So that might be more than you want to get to know. Here, I just want to show you the example of performance difference between NumPy and Python lists. So if that's what I want to show you, I'm going to type it in. Example of performance of NumPy and Python lists. And we're going, and here's the one that comes up, but we are going to, we have already imported, we're going to go my array as a NumPy range 1 million samples. And we're also going to do my list as a list range. And then we're going to multiply each sequence by 2. And then we're going to see the results. So I'm going to just show you this one. And this comes right out of the book. Multiply each sequence by 2 in IPython. Actually, I should probably go over to IPython and run it in my terminal and jump over to it. And then you can see the code snippets. And then if I actually want to run that, you would type in time for in range 10 colon my array equals my array times 2. And then you will see the results. And I'm just going to type in here. And there are the results right there. And then if you see that that's, if I go in and I type time for range 10 times 2 for x times 2 for x in my list, you will see the results are much. So you got 28 milliseconds here, and then you got 1.24 seconds here. So that's a big difference in what's happening there. And that's just something to really assess what's going on. And what I'm going to do here is just comment this out because I don't want to see it every time that I'm running it. And that's just a nice example of showing the speed difference which comes out of a textbook. NumPy-based algorithms are generally 10 to 100 times faster than their Python list. So this is really going to get you away from using for lists. The next section is where we're going to start dealing and writing NumPy arrays, a multidimensional array object, but we're going to start with single arrays. So NumPy basics, we are going to go into taking this sample. We're going to copy it over here. We're not going to use it, but it's here. And we're able to start labeling things as we go. The thing we're going to actually start dealing with here to script this so it matches up with our Python app. I'm going to call it the NumPy ND array, a multi-dimensional array object. And that's enough to start. That's going to be kind of fun as we play with it. And then the same thing, I'm going to go down here and do the exactly same thing, except since I just wrote it there. Well, it doesn't matter. It'll probably write itself. We are going to type in the NumPy array multidimensional object. Fast and very efficient, performs mathematical operations on whole blocks of data using similar syntax. So we first of all just want to create a 1D NumPy array. And then we want to, instead of just writing it here so it pops in our terminal, we want to write this into a hops component, and it should be ready to go. And it wants to give us a little sample here, but I'm not even going to do that. I'm going to prime it, and it's going to go. All I have to do is prime it with that app. You're going to write a single array, and I want you to watch some of the param access as we go. And I want you to see also what I have to do with arrays to lists, which I'm going to start with, but we're going to solve this later on. You don't want to get into for loops when doing this. Excuse me. So NumPy 1D array, it's going to give it a name, it's going to give it a description, give it an example, icon, which I don't have, so I'm not even going to do that. I'm going to go right to inputs. And the input is going to be a list, which actually I'm going to call a list, and it's going to be a list of numbers, but I'm also going to give it a hs hops param access and call that hops access and item. Even though I'm calling it a list, so it doesn't really understand that. That's the only one I need. I can follow through with that. And then the output, 1 second. You play with these param accesses and see how you can make things move faster or slower. I'm going to do an output, HS. It's going to be a hop string, which I don't want. I want a hops number output. So it's a float, and we'll call it an array. And that will come out as a list. And we'll see how this one ends up working. You sometimes have to play around with these. It really doesn't matter with a single dimensional array because you're really just making a list anyhow. But let's do the array list, and we will produce an array at that list. We're going to print that list so we see it down below. Print array. And then I also want to print type array. Oh, I want to turn it into a tuple. Type array. And then I want the array to become an array to list. And then I want to print the array now. And this, you're going to find this pretty interesting. I'm going to print the array again. And I want to print that type of array again, and then I want to return the array. And what you're going to see is a little bit of action down here. It's going to tell you a little bit what's going on. We'll save and we'll run. And you'll see down here, we have an error. Should have been 150. What was going on 150? Random. That's not going to work with 2 P's. That'll catch it. Let's try running it again. I think I hit F4. Let's stop it. I'll get jammed up here. Oh, we gotta launch my JSON again. If you do end up having that, just hit F5, go back to your app, and there should be your IP address. So let's see if we got lucky. So that's going to be there. We're going to come in here and try and make something. I'm going to take this off because we don't need that there for visualization. We're going to grab our params over here and double click, put in our IP address, /. We're going to call this the Numpy 1D array. I'm not happy with that. I guess that'll work, but I don't know. I've never done it with Numpy. No, that's the problem. Let's gotta leave this again. And if you start having trouble with this, it never should have come up with that kind of name. It should have been an underscore, and then it should be similar to here. So I think that'll cover us because I've changed the name. I'm going to hit 6 and F5. We've got the IP address, copy. Okay, let's just put it in there again just for safety. And Numpy 1D array, copy. And here, and paste it. And now if I have a list, let's just go back to see what we were doing on the other one here when we actually had a Numpy list. We decided to make a list that did this. So I'm going to grab all this data, copy, and I'm going to come back over it. I'm glad I have that as a source file because it will make things easier. Now, 1 second, we're going to paste it, drag it over here, and now we're just going to maybe do some visualization here. We're going to have this node up and running and ready. Over here, we don't need this data, and you'll see what I've done. I've made a list in a very cumbersome way with a gene pool. I pulled some numbers. I'm able to access those numbers. 1, 2, 3, 4, 5, 6 numbers. I have them in this list, 3 in this list, 3. And this isn't really necessary, but I kind of have fun with this. I flatten the list, so then I could actually bring in one. I'm just going to bring in one of the lists as a list, and I'm going to see what comes out of it. And there it is. It comes right back out as that list information. And down here, you can see what's happening. It's printing it, and it's running, if it's a class integer, the type. It also says it's a Numpy array. It then says it's this. but I cannot output arrays. I have to output lists, and that's basically what this went through. So there's a little bit of playing and fudging here, and you're gonna see this happen again and again and get neatened up as we go. But I'm gonna grab that NumPy 1D array and copy it. I'm gonna right click on here, make that the name for now, and let it just begin with that. What's nice is I can kind of bring this in as the second one and add right to that list, but you'll soon realize as we get into trees of data, these being separate, you're going to have to use entwine. And I'm going to have to show you how you output and number arrays. We don't do it at the beginning, but we're going to get into it farther when we go. So I'm actually just going to take this list from the top, 1, 3, 4, and you can see that it's trying to read an integer instead of a, because I inputted integers instead of, it's simplifying any numbers that were floats to integers, which means it's just snipping off the tail end. It's not rounding up or rounding down. It always rounds down. Actually, it doesn't even round. It just cuts off the remainder after the number. So we could change that if we wanted to put this back to number. And I think we might do that. Let's change this. But here's a little tip for you that you should know about, that if you're going to go back in here, it's good to clear down here so you don't worry about anything. It's good to go back in here, and if you're going to try another version, 02, then change that, and possibly just to remember, change this to 02, and that's kind of how I debug it, and it seems to work. So I'm going to eliminate this, I'm going to go back in, save, except I want this to be not an integer copied, I want that to be pasted as a number, and then, and this is where coming back and visiting this, I see what I wanted to clean up that I didn't catch the first time, and that's why we're rebuilding this together online. And I think we're still live on, Twitch. So what I'm going to do is I'm going to run this again with Control Save, Control S. I'm going to run it. I'll get my internet protocol number. I'll grab it. I will grab my hops. I will come down here. I will run it. And you got to be careful about number. You got to be careful where you're typing in your /. And now I've got this NumPy 1D array, 1D array _02, and that should run fine and run here, and now I should have the decimals included. So go back over to here, copy the name of it, left click double, it's there, right click, change the hops, put it in there, and then give yourself a tip on how to write this. Come back in here, because you will have to do this when you open your Grasshopper scripts again. And the thing is to remember all of your keyword names, which are here, and then you can use them. They're not going to be up here in the ribbon tools. You're never going to put them in ribbon tools. You're going to run everything fast on the Flask server, the midware, and then you're going to just use the hops node, which means you don't have to worry about any of this stuff. You don't have to worry about any plugins, nothing. You can use those to advance the script. And this is the power of really moving over to hops. You bypass the need for all of that heavy lifting from all that. So if we've got these circles here and we actually want to grab, let's say, these numbers as the x coordinates, and we could even graph them and have some fun. We could actually put these, let's just pull this out and show you a little data visualization. It's kind of fun. Let's just grab that rhino up here. You've got all these, you get all these wonderful little circles, but you can also like throw those numbers into here and here, and you could graft one. And then boom, you're starting to get some really nice geometric patterns. You're starting to visualize this data, and you could always randomize and change this and get some really beautiful visualization of running more information. And that's the power of working with NumPy and dealing with arrays. And this is going to get wild before we go into 3 dimensions. It's going to get absolutely wild, and you're going to love it. And you're going to see that I can use point grids, and I can use all different types. And when you get control of the numbers, I want you to think about you being a robot from now on, and you are computer numerically controlled. So what you want to do is control those numbers, control the geometry that's being driven by those numbers. If you get something you kind of like, then just randomize it by 10. If you really get something you like, just randomize a little bit by 1%. Wonderful tool gene pool to end up with some geometries. And I'm not even doing anything to this lifting or lofting it, but it's a nice way to control your data, control your numbers. You don't have to worry so much about all your trees and everything back here, the 9 3x3, because it makes total sense what's going back on here. If you're grafting and flattening and you're used to doing that, you can do all your acrobats here. Don't try and figure this stuff out while you're over in Visual Studio Code with Rhino and all the developer notes. I just don't see any point of it. And I'm a firm believer of this, and I don't know if anybody else believes this. So I'm going to end that, and there's some data visualization for just getting into one-dimensional arrays and doing some jive with them. And that's enough to start. So I'm going to hit File, Save Document. The next thing we're going to go is we're going to create a two-dimensional array from two lists, but I'm going to leave that for our next video. So I hope you enjoyed that. We are going to stop recording